Welcome back, everybody. It's been a while since I've done a video, but I finally got caught up a bit at work and with my new job, and so I figured I'd do a video on this power supply that I purchased recently. This is the Electronics Express Power Supply Kit Model 3010, available at www.elexp.com. So, some of you out there, you might be interested in designing or constructing your own bench power supply, or you might be interested in learning about how a power supply design works so you can integrate a power supply into a device that you've made rather than only using batteries. Or you might be interested in getting your own bench power supply for low cost. So some options are, one is you could buy a power supply. That gets real expensive though. And also you won't get the design and construction experience of working with 120 volts alternating current and a big beefy transformer. Another option is that you could design your own, and there are quite a few designs out there on the internet, but the thing is this idea also has its downsides. If you're experimenting with 120 volts alternating current and you're not really 100% confident in what you're doing, there's some very obvious potential downsides to that. So that really wouldn't be the best of ideas. Rather, I would recommend the Electronics Express Model 3010 kit. So here are the instructions for the Model 3010 power supply kit. I scanned these in on my economy scanner, so the quality isn't the greatest. But here are the entire instructions, and I'm going to post these on my website so you can preview the kit if you like. Of course, everything's in here, assembly instructions, parts list, etc. But especially of interest is if we go to page 7 in the printed document, page 9 in the Adobe document, because the first two pages aren't numbered. This is the diagram for the entire unit. So let's take a quick look at it. This is really a very classic design. You basically have a big transformer here, and then here's the wall outlet side of the transformer. Of course it's fused, and then on the other side of the transformer you basically have three separate power supplies. You have a variable 1.5 to 15 volt positive with a common ground, and then a variable 1.5 to 15 volt negative supply. These three share the one ground terminal, and then this other half of the power supply here is sort of divided into two halves here. This other supply is a constant 5 volts. The constant 5 volts is a little bit of an unusual design, especially it has some odd parts here. This here is a 0.1 ohm resistor R1 and a 0.12 ohm resistor R2. Those would be pretty difficult to find. But the top half, this is really a classic design. The positive variable part is regulated here by an LM317 and the negative by an LM337. Those are very common chips. They've been around for a long time, and they're definitely well tested and proven. Do a Wikipedia search on either of those if you're not familiar with them. Here's the 4 rectifying diodes. Of course, there's various capacitors throughout for smoothing, and these pots here are 11 and R12 variable pots. Those are the knobs on the front of the unit that allow you to vary the volts from 1.5 to 15. So now let's take a look at getting into constructing the kit. So here's the kit out of the box. Here's the top panel, and the power supply cord goes into the wall, and then these internal parts, this hooks into the internals of it. And then here's the back panel, front panel, big beefy transformer, bottom panel, and various internal parts, the circuit boards in there, capacitors, wires, etc. And here's some of the front panel parts. And there's the front panel mostly assembled. The tape isn't actually doing anything other than holding it up off the bench here to give a slightly better picture. And there's the front panel mostly assembled from the back. And here's some more of the fasteners that go into the bottom. And there's the bottom with the transformer assembled to it. And here's some more of the internal parts spread out. These are the heat sinks that go on the back panel. Some of the internal parts to the power supply. Here's a fuse, and that'll go on the back panel. And there's a back panel mostly assembled. You can see the heat sinks on the part that will be exposed to the back. And here's the circuit board and a number of the parts that go on the circuit board spread out. And here's the circuit board. It's a relatively simple circuit. It's kind of more of a classic design, so you can see the circuit board isn't especially elaborate or complicated. And here's the wires getting ready to be inserted into the circuit board that go to the other parts of the assembly. And here's the circuit board with a little bit further assembly, some of the wires on one side. And here's the circuit board with the rest of the wires attached to it and ready to go onto the base adjacent to the transformer. And there's the next step. Circuit board's now on the base, and wired to the transformer. And there's another view. The front panel starting to go on. And now here's with the back panel starting to go on. And there, we're almost done, getting there. And a few more steps, very near to completion. And there we are with the top portion on. And there's the final product. Next, let's take a quick look at a video showing some oscilloscope traces of the performance of the unit. So here's a recording of, for reference purposes, a 9-volt battery connected to a breadboard with my scope checking, set to AC coupling to check the ripple from the 9-volt battery. As you can see, the ripple from the 9-volt battery is very, very small. It's showing a peak-to-peak of about 1 to 2 millivolts. Here's a measurement with the variable voltage part of the power supply set to 9 volts and no load attached, connected to a breadboard and my oscilloscope also. So to compare, as you can see, the peak-to-peak voltage is a little bit more than with the 9-volt battery. The reading on the screen there is picking up a peak-to-peak of, sometimes it goes up to like as much as 8 or 9 millivolts, but for reference on the screen, the purple arrow is 5 millivolts. And each group of 5 hash marks is 5 millivolts. Each individual hash mark is 1, how I have the setting set on here at the moment. So as you can see, it's really, if you omit the occasional spikes, it's really only a couple millivolts of AC ripple, if even that. So really it's extremely steady. With no load, basically it's every bit as good as a 9-volt battery. And here's an example oscilloscope trace, once again using the variable voltage portion of the power supply, the power and the common with the knob set to 9 volts and a DC, kind of an economy, relatively noisy, small DC motor running there. This motor draws 10 to 20 amps with no load, which currently it's turning with no load on it. It draws about 10 to 20 amps in that condition. And as you can see, all things considered, really, the ripple is amazingly low even now. So once again, for reference, that purple arrow that sets the trigger on this scope, that's at 5 millivolts. So as you can see, the total ripple is maybe about 5 millivolts. Of course, there's spikes that are more, but on the whole, it's really very low. So this power supply, basically for any purpose you would really need, is extremely steady and has essentially no AC ripple that's of significance. In case anybody's wondering, here's the breadboard setup I used with the oscilloscope and that 9-volt DC motor as a test load for the previous oscilloscope traces. So in conclusion, the Electronics Express Power Supply Kit Model 3010 gets a definite thumbs up. I've got some more videos planned for the very near future. Please check out my website, www.18f4550.com, and on YouTube, 18f4550 videos. Happy soldering, and see everybody next time.